It's Soren Sorensen's son. Get it right here. pH scale once late at night.
I'm Fabio. I'm a Crabbio. Put me in a lab and I'll be Fabio. Ah.
I don't think raps are game.
Not yet. We're not going to crack it today. Maybe tomorrow.
Tomorrow evening, yeah.
Okay.
Hoods down, hats off, crabs away. What we've got here is a nice image, a spitting image.
Spitting image. This is
Soren Sorensen.
Yeah, that's a clever Greco portrait. You can have that. And he's a Danish chemist, and he sort of gave us the pH scale.
Yes, which you've heard of, but we're now going to take a few steps further.
Yeah. From GCSE, you knew it was between 1 and 14.
Yes.
And it seems from GCSE that you don't assign the numbers meaning they're just arbitrary numbers. 1's very acidic, 14's very basic.
Yeah. It actually goes a little bit further than that.
It does. In A2, you need to know that it goes down to at least -1 and up to 15. Doesn't have to stop there, it can go further because it's all to do with the amount of hydrogens that are released.
And that's something else you need to know. There's a logarithmic relationship between them, which we'll talk about in just a second.
Yeah.
So a pH of 0 has a H plus ion concentration of 1 mole per decimeter cubed.
Yeah.
Because that's what this is all about, this H plus ions given off, protons given off.
So the logarithmic relationship works by their, so your 10 is to the minus of your pH.
Yeah, and that is equal to your hydrogen plus given off. So that means that -1 must be
1.
10 to the power of 1.
Yeah,
which is
then
10.
10, and that's why 15 is then such a low number.
10 to the minus 15
is 1 over
10 to the 15.
Yeah, which is a small number.
Because it's so base, it doesn't give off protons.
Yeah, and that's why lower numbers are much more acidic. And you have to know how to convert these to one to the other.
Yeah.
So I should go through that.
Yep, we definitely should, because what it will often ask you is to define pH as well as a common question in exams, and rather than defining it in words, you'll get marks for the equation. So
yeah,
let's rearrange that now. 10 to the power, we've got a special thing called log if you don't do maths.
Yeah, if you don't do maths, what you can do here is you can apply this to both sides. If you log both sides, you'll have log of H, and it will just get rid of the 10 on the other side.
Well, indeed, because what this is, the log button on your calculator, in case you don't know, is naturally log to the base 10.
Yeah.
Now, you don't need to know what that means, you just need to know that that will get rid of the 10, so that will just equal minus pH.
And then you can rearrange it to find pH, which means
you
negative.
Take minus to the other side, so it's minus log of the concentration of H plus. That plus there should be inside the bracket, really.
Yeah.
And what they'll do is probably give you this concentration, or they'll give you a pH, but it's more common they'll give you the concentration, so you can either remember this and then be able to rearrange back to that.
Yeah.
Or remember that and rearrange to this.
Either way, you got that. So now we've got out of our heads what pH actually is.
Yeah, measure of the protons given off.
Then we can go through a few things. Start with a few revisions of AS.
Yeah.
So in AS we talk about partially and fully dissociating.
Strong acids fully dissociate, they fully split into their components.
Yeah.
So HCl splits into hydrogen ions and chlorine ions.
Straight away, but say ethanoic acid, it will only give away the H after the COOH, and the other ones will remain, and it will do this slowly.
Yeah, so that's partially dissociating, that's what forms the difference between a strong and a weak acid.
Yeah.
Now, because we've taken it a bit of a step further, we've got this pH relationship, we're looking at the H plus given off, we can now apply another constant, another one.
Yeah, there's a lot of constants in A2 chemistry, so we have our acidic constant, which is Ka.
Acid dissociation constant.
Yeah.
And dissociation.
No, I'm not sure either. This one pretty much just applies to strong acids. It does. You can use it with weak acids. You have to use an assumption which isn't quite true, but that's something that's not really in the course. You can look into it if you like. So
Ka as a thing, if you just want to work out the acid dissociation constant. I've got acid D because I don't have to spell dissociation.
It is like all, apart from rate, it is concentration of products over reactants.
Yeah. So if we take the example of HCl, you know that breaks up, it's really reversible, into H plus and Cl minus. These are your products. So to work out the Ka of this particular one, you'd have Ka is equal to the concentration of the products.
Yeah, which would be your 2 ions over the concentration of your reactants.
Absolutely, and that'll just give you a value which you can compare to other values to see what a strong and a weak acid is.
Again, it'll work in the same way. If you're stoichiometry, if you have numbers, you'll then put those to the power, whatever.
What you'd often find in exams is a proper question for you to give you comparable results. They will give you, if I do it in red, they'll give you that, that, and that. So what you're actually working out is this, which you can then apply to this formula to work out the pH.
Yeah.
Is often the way around them do it. They may well give you these things and just ask you to work out that. That's quite a simple one. You'd be lucky for that.
So fingers crossed for the exam, but that sort of thing.
There's another way of expressing this in a simpler form.
There is, and that's pKa.
Yeah, which again is a logarithmic relationship.
Yeah. So we have
pKa is how it's dictated, equals 10 to the minus Ka. So it's the same logarithmic relationship, and that's still a minus there.
Oh.
And you'd rearrange in the same way to find Ka.
Yeah.
This might be a longer way that they'd ask you to find out H to give you more marks. Is first give you that. So then you'd have to work out that to put into there, to work out that to put into there. It's just thinking about what you have, what you need to get to.
Yeah, which is always a good sort of way of thinking in every exam, working out what you have to start with and ways of getting to what you want to get.
And that's another constant. This is to sum up the video really. It's the acid dissociation constant after what pH really is. Thought we'd intro with a rap. I think we can go sign a deal tomorrow.
I think someone comes almost on the phone with our producer over there.
Yeah, so we should speak to our producer. We should also hire one.
Oh yeah, that's a good idea.